Hello everyone, my name is Bakshi. I would like to start by thanking the organizers for giving me the opportunity to speak at the Tech Topology Conference. So today I will be talking about the Kaufman-Brackes-Kane module of the connected sum of three manifolds, and in particular I will be talking about the structure of the Kaufman-Brackes-Kane module of the connected sums of handle bodies. So what is a Skene module? Well, Skene modules are essentially generalizations of all the various polynomial link invariants in S3 to arbitrary three manifolds. They are three manifold invariants, and they were introduced by Josip Prititsky in 1987 and independently by Vladimir Duraev in 1988. And there are many different Skene modules. And in this talk, we will focus on the Kaufman-Brackes-Skene module. So how do we define the Skene module? Well, we consider formal linear combinations of ambient isotopy classes of unoriented framed links in an oriented three manifold. The base ring over here is a commutative ring with unity with an invertible element A. And now what we do is that we mod out by the submodule, which is generated by these two expressions. So the first one is the Kaufman-Brackes-Kane expression, and the second one is the trivial component expression. And once we mod out by these two, what we get is the Kaufman-Brackes-Kane module, which we denote by S2 comma infinity. So this is an example of the Kbsm of the thickened annulus. So you have this link, you can mod out by the Kaufman-Brackes-Kane relation, then you can use the trivial component relation to simplify and get this element in the Kbsm. Here X is the homotopically non-trivial curve in the annulus, and this is the empty link. So what are some properties of Kbsms pertinent to this talk? Well, the first one, due to Josip Prititsky from 1987, says that if you have one manifold which is obtained from the other by adding a two handle along some simple closed curve lying on its boundary, then the associated embedding yields an epimorphism of the Kbsms of the two oriented three manifolds. And moreover, the kernel of this epimorphism is generated by all two handle sliding relations. And then later, Josip Prititsky computed the Kbsm of oriented surfaces times an interval and said that it is a free module and is generated by the empty link and links in the surface which have no trivial components. And this in particular applies to handle bodies, since handle bodies are thickenings of planar surfaces. Now, what are some examples of Kbsms? Well, there have been very few computations done, largely due to the fact that computations are very hard for the Kbsm, and moreover, whatever we have is over various rings, for example, the ring of Laurent polynomials and the field of rational functions. So this is almost a complete list of all the three manifolds for which the Kbsm has been computed. Now, sometime in the year 2014 or 15, Edward Witten conjecture that the Kbsm for any closed-oriented three manifold over the field of rational functions is always finite dimensional, and this was resolved in the affirmative in 2019 by Gunningham, Jordan, and Safronov. However, this is not true when you work over the ring of Laurent polynomials. And later, Julien Marchais conjectured the following about the Kbsm of closed compact oriented three manifolds over the ring of Laurent polynomials, and he conjectured that these Kbsms have this nice decomposition into free modules and torsion modules. Now, while all of the examples listed before satisfy Marchais' conjecture, I show that this is not true in general. The Kbsm of two copies of the real projective space is the counterexample, and moreover, this Skene module does not split as the sum of cyclic modules, and this is due to Maciek-Myszkowski from 2011. So, well, all of the examples listed before satisfy Marchais' conjecture. The moment we have connected sums, we have this outlier. So to understand the structure of the Kbsm of connected sums of three manifolds, we need to understand the structure of the Kbsm of the connected sums of handle bodies. So Josip Prititsky in the year 2000 had this theorem. He stated this theorem, this was published as well, about the Kbsm of the connected sums of a genus N and a genus M handle body, and he stated that this Kbsm is exactly the same as the Kbsm of a genus N plus M handle body, modded out by the submodule, which is essentially generated by handle sliding relations of this form. So these expressions over here are exactly due to these handle sliding relations, and nu zk is simply a modification of zk as shown. So he stated this theorem about the Kbsm of the connected sums of handle bodies. However, more than 20 years later, I show that this theorem is not true and that this submodule needs to be generated by more handle sliding relations than stated in this theorem. And in particular, I show that the natural epimorphism due to the embedding of H3 into H2 connected sum H1 is not an isomorphism. And then I generalize this to connected sums where n and m, where n plus m is greater than or equal to 3. However, I conjecture that the Kbsm for the connected sums of two solid tori, meaning when n and m are exactly 1, has the structure stated in the theorem before, and we were able to show this a couple of weeks ago. So this is joined with Tanglea and Joseph Tritici, and we show that the natural epimorphism due to the embedding of H2 into H1 connected sum H1 is exactly an isomorphism. So some future directions, the goal is to study the structure of the Kbsm over the ring of Laurent polynomials. So we can generalize the previous result to connected sums of length spaces or to connected sums of S1 times S2 and S1 times S2. And then what is the structure of more complicated manifolds, for example, the prism manifold or the Seifert-Fibert manifolds. So this is some work in progress. Thank you.